it's Miss Northam, and today we're going to be doing a quick lesson on adding integers. Remember that an integer is a positive or a negative whole number. Now, let's look at what the rule same signs add and keep really means. Same signs. I could have the problem 4 plus 3. In this case, I have two positives, same signs, right? Same signs add and keep. So if I added these, because I have the same signs, I know I'm going to get 7. Now let's say that I have the same signs, but this time they're both negative. So I could have negative 4 plus negative 3. Now what is that answer going to be? First of all, I'm going to show this with some parentheses because we have this plus a negative. You really don't want to have double signs without parentheses separating those signs. So this would be read negative 4 plus a negative 3. And that is going to equal what? Well, we can model that with our counters. I'm going to use green counters to represent positive numbers and red counters to represent negative numbers. And in this example number 2, the only thing I have is negatives. So here we go. We've got negative 4. And I have a group of negative 3. So when I look at this in total, if I have a negative 4 and a negative 3, when I look at what I have in total, I have negative 7 total. So again, same signs, I added, and I kept the sign. So in this case, it was a positive 4 and a positive 3. I added, and my answer was still positive. Same signs add and keep. In this case, I had negative 4 plus a negative 3. And again, I'm going to add 4 and 3, which is 7, and I'm going to keep the sign that is there. So my answer is negative 7. The next two are a little bit trickier. Our rule is going to change. Let's talk about our second rule. The next rule that we're going to learn is different signs subtract. Keep the sign of the largest absolute value. So different signs subtract. And remember, we're talking about adding integers. But when you have different signs, your rule is going to be to subtract those. So let's look at some examples that will explain why. In the two examples shown here, I've got different signs. Got a negative 4 and a positive 3 in this example, and a positive 4 and a negative 3 in the second example. So we have different signs. So our rule is going to be to subtract. But let's model that first to make sense of what we're doing. So here we have a negative 4. So I'm going to pull up 4 negative counters. 1, 2, 3, and 4. And we have a negative 4 and positive 3. So this time I need 3 counters. 1, 2, and 3. Now, if you remember from our lesson, we talked about how the additive inverse property tells me that I can create 0 by adding opposites. So here I have a positive and a negative. If I combine those, that makes 0. Here I have a positive and a negative again. If I combine those, that's 0. So I'm just going to cross those off. Another positive and a negative, which makes 0. And what am I left with here? I'm left with negative 1. I know it's negative because it's red. That represents red. So let's look at our rule. Different signs subtract. So 4 minus 3 would give us 1. And then it tells us to keep the sign with the greatest absolute value. Well, which number is farther from 0? Negative 4 or positive 3? Negative 4 is 4 steps away from 0. Positive 3 would be 3 steps away from 0. So negative 4 has a greater absolute value, so our answer is going to be negative. And we can see that in the picture. All right, the next example, we have a positive 4 and a negative 3. So I'm going to pull up 4 positives. 1, 2, 3, and 4. And then I need 3 negatives. 1, 2, and 3. Okay? So again, if I look at my 0 pairs, I can cross off. Whoops, see if it'll let me cross off that. 1 set, 2 sets, and 3 sets. And what am I left with? I'm left with a positive 1 that I could just write as 1. So if I followed my rule, different signs subtract. So 4 minus 3 gives me 1. So there's my numerical answer. And then I'm going to keep the sign with the highest absolute value. So this is 4 steps away from 0. Negative 3 is 3 steps away from 0. So this positive 4 has a greater absolute value. Therefore, our answer is positive, which is shown here when I have 1 green chip remaining. Let's practice a few more to make sure that you have got this down. We've got a positive 5 plus a negative 2. So if we're using our counters, 1, 2, 3, 4, and 5. And then we have negative 2. So I'm going to bring up 1, 2, red counters. So these show opposites, right? So this and this is an opposite. We have a positive 1 and a negative 1. That makes 0. Here we have another positive 1 and negative 1. That makes 0. So now we've canceled out everything that we can, and we're left with 3 positive counters. So our answer is 3. So 5 plus a negative 2 equals 3. If we thought about that in terms of like a real world application, maybe we might say that the temperature was 5 degrees and then it dropped 2 degrees. So 5 plus a negative 2. That gives us a temperature of 3 degrees. Another example of that might be that you have $5 and you borrowed $2 from your mom. So you're in debt now $2. So you had $5 and now you borrowed $2 from her. So now you only have really $3 remaining. Okay, let's do another one real quick. So which rule is going to apply here? Do we have same signs or do we have different signs? We have same signs, a negative plus another negative. So same signs, our rule is to add and keep the sign. Let's model it to make sure we understand. We have 1, 2, 3, 4, 5, 6, and 7. And then we add to it 2 more negatives. In this case, nothing will cancel out because we don't have any opposites. We have all negative integers. So when I look at what is displayed, I end up with 9 counters. They are all negative counters, so my answer is negative 9. Add 7 and 2 and keep the sign. Okay, so here is another example of different signs. We have a negative 2 and a positive 8. So different signs. I've gone ahead to model that. I have 2 negative counters and 1, 2, 3, 4, 5, 6, 7. I need 1 more positive counter. And then if I look at what's available here to cancel out via my additive inverse property, you can cancel 1 set of opposites, 2 sets of opposites, and this is what I'm left with. I'm left with 6 counters, and they are green, meaning my answer is going to be positive. And if I think about that just using my rule, it is different signs, subtract. So if I subtract 2 from 8, you're always going to start with that larger number and just subtract. So 8 minus 2 is 6. And then I'm going to keep the sign with the greater absolute value. And positive 8 is 8 steps away from 0. Negative 2 is 2 steps away from 0. So that positive sign has the greater absolute value. And so my answer gets the positive sign. Try these 4 examples out on your own using the same signs add and keep or different signs subtract rule. The answers will come up in just a second, so pause it, solve them out, and then check your work. Okay, how'd you do? 9 plus negative 3 equals positive 6. Negative 7 plus 1 equals negative 6. 6 plus negative 4 equals 2, positive 2. And negative 1 plus 7 equals positive 6. All right, so how'd you do on this lesson today? You will have an opportunity to practice using your interactive notebook. Do your best work and let me know if you have questions.